The remains of ancient life are often most preserved through which process? So the remains of ancient life, we're talking about fossils. Or in archaeology, more modern terms like artifacts from the recent human history. But the remains of ancient life, how they're preserved. Freezing, it does happen. They found like elephants in like the frozen like Siberia area. Burial in sediment, so buried in a mudslide or in the sand, finding a fossil. Entrapment in tar, there's the La Brea tar pits where they have found fossils. And dying out. So the question here is really tough because it gives you three reasonable answers that are ways that fossils are preserved. But it's asking you most often, and most often fossils are found in the ground, buried in sediment, in sedimentary rock. So the answer is B, burial in sediment. Okay, the fossil at point X right here has been dated to be 65 million years old. What can relative dating indicate about the fossil at point Y? Alright, so remember, relative dating isn't going to give you an exact age of the rock, but it's going to tell you, relatively speaking, which one's older or which one's younger, based on which one's higher and lower in the rock layer. So if you look really close, fossil X and fossil Y are in the same layer of rock, so they're roughly the same age. If fossil Y would have been found down here, then you would know fossil Y would have been much, much younger. Now, let's look at our choices. Is it the age the organism died? Remember, relative dating doesn't give you an age, it gives you a older or younger relationship. Is it the type of environment the organism lived in? Well, you might be able to tell about the type of environment if you knew which type of rock this was, but it's not giving you that information, so that's not the best answer. The distortion of the organism by the fault. Here's the fault, but just knowing where they are doesn't tell you how distorted the organism was by the fault. That's kind of the silly choice. The similar time period in which the organism lived. Yes, D is the right answer. You can tell that they lived at about the same time in history because they're found in the same layer of rock. Rocks found on land are up to 3.8 billion years old, but those in the ocean are no more than 180 million years old. Using the information, during which era could parts of the ocean floor have formed? Well, first thing it's kind of telling you is that the seafloor is always recycling itself. It's being subducted and melted, and then in the middle it's being recreated where like there's seafloor spreading and all the plate tectonics that we learned about. Now, this question, you don't really have to know anything about that. It's just asking you a simple question. What era, look at the table, see era right here? There's the Cenozoic, remember the age of mammals, the Mesozoic, middle life, the time of the large reptiles like dinosaurs, the Paleozoic era, that's your ancient life in the oceans generally, and then there's your Precambrian period. Alright, so which of these eras, now look at your years, which of these eras is in the 180 million years ago? That's where you'd find the oldest seafloor. So if you look, 180 million years falls in the Jurassic period in the Mesozoic era. So our best answer here is not the Triassic period, because number one, Triassic period was over 190 million years ago, and number two, the Triassic is a period, not an era like the question asked. The Paleozoic, that's way too old. The Precambrian, way, way too old for seafloor, current seafloor. So the answer is D, the Mesozoic era. The diagram represents areas below the surface of the Earth in which fossils have been found. The fossil located in which label area is most likely the oldest. So this is just a really simple relative dating question. It's asking you which is the oldest and which is the youngest of all these rocks. So our youngest rocks are always on the top, and our oldest rocks are always on the bottom. Now, in this diagram, we have a thing right here called an igneous intrusion. This igneous intrusion is breaking through all of these layers. In order for this igneous intrusion right here to have broken through all these layers, these other layers had to be there first, or there would have been nothing for this igneous intrusion to break through. So if you want to rank these in order, this is the youngest, this would be the second youngest, the third youngest, the fourth youngest, and the fifth youngest. Now our question over here is even easier because it doesn't have an igneous intrusion to kind of throw you off. It's real simple. This is the youngest rock. Here, number 1 is the next youngest. Number 2 is underneath number 1, so it's the third youngest or older than number 1. And number 3 is going to be older than number 2 and older than number 1 because it's underneath them. And then we've got, now here's the tricky part. Look at number 4. If you look at number 4, it looks like it's under 1, 2, and 3, but it's not. Look at number 4. It's the same rock layer as number 2. So number 2 and number 4 are the exact same. And number 3 is underneath that layer. So the fossil located in which labeled area is most likely the oldest? Number 3 is the oldest because it is underneath 1, 2, and it's underneath number 4. So C, number 3. Okay, this is a pretty easy question. This is a relative dating question. Again, there's lots of those in geologic time. Just remember our youngest rocks are on the top and our oldest rocks are on the bottom. Now, in this section of undisturbed sedimentary rocks, meaning there hasn't been an earthquake to have shifted the layers, there hasn't been an igneous intrusion, there hasn't been mountain building. So in this undisturbed sedimentary layers, which best describes layer number 2? So what do we know about layer number 2? We know layer number 2 is older than number 1 because it's underneath it. So number 2 had to have already been here before rock layer number 1 was formed. We also know layer number 2 is going to be younger than layer 3 and layer 4. So here we go. It was intruded into layer 1. No. It was intruded onto layer 3. No. It was deposited after layer 1. So if it was deposited after layer 1, that would mean it would be younger than layer 1, but we know that's wrong because it's underneath it and it's older. It was deposited after layer 3. So layer 2 was deposited after layer 3 because layer 2 is on the top of layer 3 and it's the younger rock. So our best answer is the last choice, J. It was deposited after layer 3. These geologic cross-sections show the location of 3 fossilized species, W, X, down here, and Y, found in rock layers at 2 nearby sites. Species X is probably the oldest species because it is found. So it's telling you species X is the oldest, but it's asking you why. And the reason that species X is probably the oldest species is because it's in the oldest rocks. And we know that the oldest rocks are always at the bottom. And if you look at these 2 cross sections, even though they're in different places, kind of like this picture here, even though they're in different places, they're the same rock layer. Look here. We have a rock layer here and a rock layer here. It's the same rock layer. It looks like we had a volcano eruption. And we can see the layer of volcanic ash here and the layer of volcanic ash here. And then underneath that we had sandstone, which usually indicates a beachy kind of area, a shore area. And underneath that we had a limestone layer, which kind of indicates that the land was under the ocean. It was under a large bed of water at one time. So same place goes through all these different changes at the same time. So the reason X is the oldest species in this picture, in this diagram, is because we can tell that the limestone is the oldest rock because it's in the bottom. So species X is probably the oldest because it is found below species W, okay? In the lowest layer, good answer. Above the ash layer, well that's just wrong, it's below the ash layer. In sandstone, species X is not in sandstone. It tells you right here that it's in limestone because it's the same rock. So now you have to pick between below species W, that's true, and that makes it older than species W. But that does not make it older than species Y. What makes it older than species W and species Y is the fact that species X is G in the lowest layer. So our answer is G. Modern geologists have argued that a global catastrophe may have caused the extinction of the dinosaurs. According to these scientists, what was this catastrophe? It's just a memory question to see if you remembered what we learned in class about the extinction of the dinosaurs. And our most accepted theory of the extinction of the dinosaurs was multiple asteroid impacts on the Earth, which really would have changed the climate and the landscape and the, basically everything about life on Earth. So our best answer here is A, an asteroid impact with the Earth. All right. All these other things may have happened and they may have contributed, but A is our best answer, an asteroid impact. Which of these is the best indication of the relative age of a rock layer? Alright, there's a big law of geology called the law of superposition, and it's a principle that's really simple. That states that the younger rocks lie above the older rocks. And if you think about this, this is very, very much common sense. You can't have this layer of rock on top of this layer of rock unless this layer of rock was already there. So it's very, very simple, but it always holds true. It is a law, it's not a theory. So which of these is the best indication of the relative age of a rock layer? Not the thickness, not the chemical makeup of layer, not the rock layer, but the position of the layer compared to other layers. So that's what relative dating and relative age means. So our best answer here is C. Okay, it's a very challenging question. So it's asking you to identify the geologic time in which these organisms first appeared. A couple ways you could approach this. I hope that the first way you would approach this would be to look at this geologic time chart and realize it's in order. The Precambrian period is the time of the first appearance of single-celled life, the most simple form of life. The Paleozoic, if you remember, the Paleozoic meant ancient life. The Mesozoic was middle life, the time of the large reptiles like dinosaurs. The Cenozoic, that's our current time period. That's the age of mammals. So if we look at these, just which one comes first? Birds, bacteria, fish, or humans? So the most simplistic beginning organisms of life would be the first bacteria. So you would want to draw a line or drag this, if you're on a computer test, drag first bacteria to the Precambrian time right here. Prokaryotic fossils found in the Precambrian. So you drag first bacteria to this one right here. Next, then what comes next? Fish do. Life in the ocean really evolved rapidly during the Paleozoic period. So you would drag the first fish right here. So our last two choices would be birds and humans. Now, hopefully you've caught on to this by now, but humans have only been here in this very, very brief period of time, right along this line at the very, very end of the current Cenozoic era. So our next step would be to put the first birds right here, appearing at the very, very end of the Mesozoic era. Well, some of the very, very first birds appeared towards the middle, but birds as you think of them kind of start to appear towards the end. And then right here our first humans appear in the Cenozoic period. So one more time, you should have had first bacteria here, first fish here in the Paleozoic, first birds in the Mesozoic, and first humans in the Cenozoic. About 2.0 billion years ago, complex organisms began to inhabit the Earth. These complex organisms developed primarily because of our number one thing that led to the survival and evolution of more complex organisms was oxygen. And all that oxygen came from those early photosynthetic organisms that converted the Earth's carbon dioxide into oxygen. And so our best answer here is changes in atmospheric gases, A. So that's the correct answer. Sunlight being absorbed by the land is a good, tricky one that a lot of kids might choose. And because you'll overthink it, and you'll think, well, sunlight is what the plants use to make their own energy and release the oxygen. But there had always been sunlight on the earth. But once the change in the atmospheric gases happened, that's when our complex organisms evolved. So our best answer is A. Volcanic ash has occasionally formed molds of animals. This occurs when the ash covers the animal, and so a mold of an animal would be like a fossil of an animal. So which one of these four choices best explains this phenomenon? So this occurs when the ash covers the animal and replaces the animal's soft tissues. Okay, not a terrible choice. Enters the animal's body cavity. It's not the answer. Hardens before the animal decays. So a mold would definitely form if the mold hardened into rock before the animal decayed, like this picture. Mineralizes the animal's bones. Also an interesting way they explain that, and they're trying to get you to pick the wrong answer here, but pick the obvious answer. The answer here is H, hardens before the animal decays. Well logs are used by oil companies to correlate geologic formations based on the formations in well A. Which geologic formations are missing in well B? So basically they're telling you is they found a layer of rock, multiple layers of rocks that had this description. Sand number 1, represented by this symbol. Shale number 2 by a straight tube. Sand number 3 with this symbol here. Shale 4, you can see the big brick that's limestone, and so on. Alright, now when you went to well B, they couldn't find anything above this symbol right here. So if you look at this, what they're asking you is, what is actually up here? What's above sand number 3? Because this is sand number 3, and so is this. This is a really easy question. It's just worded in a strange way that makes it difficult. All they're asking you is, which one of these, your geologic formations, goes right here? And since if you look at this shape, this is clearly the same rock layer, see how they all match up? Then what goes right here? Well, shale number 2 goes right here. So you were to grab shale number 2 and drag it to here. And what was above shale number 2? Sand number 1 was. So you would drag sand number 1 right here and put it on the top. And now the last part was asking you, what goes here? And if you look at the symbol for sand number 7, you can see it right here. Here's sand number 7. And you can find sand number 7 over here. All you have to do is check well A and see that shale 8 follows the pattern. So this is just a completing the pattern question. So shale number 8 goes right here. Shale number 2, you would drag right there. And sand number 1, you would drag to the very, very top. The hypothesis for the cause of the dinosaurs' extinction that has the most scientific support links their extinction to, and we've talked about this already before, but our most common belief in the extinction of the dinosaurs was a large asteroid impact. And that's not just a wild theory that comes out of nowhere. If you look back at rock that's about 64 million years old, you can see this layer right here. And once you test this rock layer, it has levels of the element iridium that are higher than anywhere on the earth. So that strongly suggests that this layer of iridium that's found literally in the rocks all over the globe, and it has this extraterrestrial amount of iridium, probably indicates a very, very large asteroid impact, and then its ash settled back down, caused a global catastrophe, and led to the extinction of all the very large land animals. Alright, so our best answer here is J, a large object from space hitting the Earth. So which area is most likely the oldest section of rock? So remember our law of superposition. The rocks on the top are always the youngest rocks, and our rocks on the bottom, as you can see here with these little trilobites in them, this ancient life, the rocks on the bottom are very, very old, and relatively speaking, they're older than the rocks above them. Alright, so now on this level, 1, 2, 3, and 4, we need to figure out which one is the oldest. Alright, 1 is up here on the top, so it's definitely not going to be the oldest. Now look here at 3. Rock 3 actually breaks through rock level 4, it breaks through rock level 2, and it breaks through rock level 1, which indicates that actually rock 3 is the youngest, because rock 3 broke through rock 1. So in order, we have the youngest rock, then number 1 would be the second youngest. Rock level 2 is below rock level 1, so it's older than rock level 1. Now, rock level 4 is below 1, below 2, and below 3. So our best answer here for the oldest rock is rock level 4, D. If you look over here at this picture, I just wanted to give you a real-life example of an igneous intrusion. And if you see right through the middle of this rock, we have something very different. You can kind of notice it right here in this light gray and this dark gray area right here. We've got an igneous intrusion, which is a volcano eruption which led to magma breaking through the rock layer and hardening as it was breaking through this rock layer. Alright, so let's look at the diagram now. In the illustration shown, which layer is an example of an intrusion? Remember, intrusion, like an intruder, somebody that breaks through your, breaks in your home would be an intruder. This is an intrusive rock, a rock that breaks through the other layers. And after you understand what the intrusion means, it's very obvious which one is doing that, and that's number 3. And remember, intrusions are always the igneous rocks, and granite was the phaneritic igneous rock that comes from the cooling of magma under the ground. And we see shale here, a sedimentary rock, limestone, another sedimentary rock. So our best answer is C, number 3. Which of these pictures shows the last in the sequence of events? So a couple ways you can think about it is which one happened most recently, or just put them in order and find out which one happened last. And if we look here, we can see letter C, that our sediment and our rock layers have been deposited horizontally. This is the traditional, normal way that a rock layer is deposited. So C is what happened first. And then you can see here in letter A, our rock layers start to get deformed. Maybe there's some compression forces, maybe there's two continents colliding, but something is disturbing these rock layers. So letter A happens second, and then we see letter B and letter D, and we can see that there's a big crack in the earth. This is a fault, and you can kind of tell by looking at this fault that we've got two walls. We've got a hanging wall, and we've got a foot wall over here. And we can also see that the rock layers have slid. Now you just have to decide which one happened first, B or D. And if you look at these pictures, it appears that D is the earthquake and letter B is farther along, maybe following subsequent earthquakes, where the hanging wall has slid down even further. So letter B is your best choice of which one of these 4 pictures happened most recently or last in the sequence of events. So B. The map shows some of the bedrock in Virginia. Which of these has the oldest exposed bedrock? So first thing we just want to think about real quick is, what does exposed bedrock mean? And if you look at this little picture over here, you see this random large igneous rock that's kind of protruding out of the earth. This is exposed bedrock. So something that you can see on the surface. So if you can look here at the map, we see lots of different rocks on the surface. So we just got to figure out which one is the oldest. And remember, our law of superposition states that the oldest rocks are always going to be at the bottom. Like we have these 700 million year old rocks right here. And up here we got these 60 million year old rocks, 70 million year old rocks from the end of the Cretaceous period during the time of dinosaurs. So which one is the oldest? Well, this is the oldest rock, but it is not exposed. This looks like the second oldest rock, and if you look right here at Hightown Valley, this rock is exposed. So our oldest rock is going to be found at A, Hightown Valley. Which of these parts of a saber-toothed cat was most likely to become fossilized? So remember, fossils are going to be the hard parts of an animal, the bones, the teeth, not so much their hair or their skin or any of their other tissue of their body. That all decomposes and goes away. So our best answer here is not hair, not skin, not the muscles, but the saber-toothed tiger's jaws and teeth. That's the most iconic part and the most famous fossilized part of this extinct animal. So J, jaws. According to the geologic time chart of Virginia shown above, the most recent formation in Virginia is the... So, all you really have to know is what MYA means. And if you didn't catch that, then you probably had a hard time with this question. But MYA means million years ago. Like this is a picture of the Earth 400 million years ago in the Devonian period. You can see the continents are in very radically different places than they are now. So, most recent, there's 505 million years ago, 420 million years ago, and you can tell this is kind of going in a linear order. So the most recent event in our area is, believe it or not, the formation of the Chesapeake Bay. That's only 0.011 million years ago. So in geologic time, the Chesapeake Bay is pretty young. So the answer is G, Chesapeake Bay. So what appears to have occurred at the area labeled B? If you look here, this is a bunch of different rock layers, and you can see level B is no longer level. It is a little bit tilted. Alright, and if you just look at this picture for a second over here of the Grand Canyon, which was carved out by the Colorado River, you can notice that rock layers, and you can see them, they're all like the same color, they look very similar, but all of them in this picture are basically flat. So, which one of these is a true statement? Sediment was deposited on sloped ground. Is that why this is tilted? The answer is no. All rock layers start out horizontally. Sediment was deposited on sloped ground that later became level. This was the trick. They basically gave you the opposite answer. Alright, so G is not true. Sediment was deposited on level ground, like all rocks start out as, and that later was tilted. That is your best answer, H. So what happened? Something happened to tilt this rock layer, something involving plate tectonics. So the answer is H. We have a charts and graph question that's asking what geologic time period, like Jurassic, Triassic, Permian, or Carboniferous, did all of these species survive and live at the same time? Alright, so we got species A, which began in the very end of the Carboniferous period and lived through the Permian and the Great Extinction into the Triassic, and even all the way a little bit of the species survived into the Jurassic. Species B really only lived in the Permian and the Triassic. Species C had the shortest lifespan of all of these four species, where it only survived in the Triassic period. And D began in the Triassic, but really flourished in the Jurassic and all the way into the, it's not here, but this would be the Cretaceous. So which one did all four of these animals live at the same time and could have met and hung out? And the only answer here is they all four were alive in the Triassic era. So the answer is the Triassic period, B.